Hello, my dear students. I am very pleasure and happy today to meet you again in the next term or second term. We have finished the first term, Alhamdulillah. We are going to explain some lessons in the second term and try to concentrate with me and don't go away. First, we will go to algebra lesson now. We have the new lesson is matrices. Matrices is an algebraic lesson. Yes. Okay, we have the lesson here. We have algebra lesson called matrices. What is the matrices exactly? The matrix is a mathematical mean, okay, used for expressing data in a fair way to be easy and rapidly to carry out. Carry out what? Carry out the mathematical operations that are concerned with these data. Okay? We use that in math, science, physics, and particularly in computers and electronics. So, my dear students, we will explain to you some lessons about matrices. You have the unit, complete unit, studying matrices. We have here an introduction of it, and the matrix, as we know, or as we said now, is a mathematical mean. Okay, it's a method, it's a way used for expressing data in a fair way and easy way to rapidly and easy carry out the mathematical operations. Okay. Let's move to the second example. We have an illustrating example here to be easier for you to know what is the matrices as it is. Let's concentrate here. Illustrate example. We have an example here. If we have a factory in our country produces 3 kinds of electronic sets. If we have factory produce 3 kinds of electric sets: TV sets, washing machines, and refrigerators. And the factory has 2 branches. The first branch called X, the second branch called Y, and the average weekly production of the factory of these sets is shown in the following table. We have a table here. Look carefully, my dear students. We have a table. We have said about a factory. This factory produces 3 types of sets, of electronic sets. First, TV sets. Second, washing machines sets. And refrigerators sets. And this factory has 2 branches called X and Y. X and branch Y. Branch X and branch Y produces what? Produces these 3 TV sets and washing machine sets and refrigerators sets. What are numbers? TV sets here is 50 for the production of branch X and 74 for branch Y. Washing machines, the branch X produce 40 and branch Y produces 25. Refrigerators, branch X produce 37, branch Y produces 49. And we would like to express this data by easier way, which is the number matrix. We have here a matrix. We have 2 parentheses here, like that. And we will write these numbers as follow. Here 50, 40, and 37. Here 74, 25, and 49. So all these data can written as the following and easy way as a matrix. This matrix, we have elements here in a row, and second row we have also 3 columns here. So these numbers written as this way, and this is the matrix. Okay, let's see the matrix again. The matrices lessons are very easy and enjoyable, and you will enjoy it, and it's easy for understanding. We have the last matrix here: 50, 40, 37, 74, 25, 49. We have how many rows here? What is the row? Row here is this row. This is a row, and this is the second row. Okay, so we have how many rows? Yes, we have 2 rows. And we have also columns. Look carefully at me. We have first column, we have second column, we have third column. So we have 3 columns. Each number is called what? Each number of these, 50, 40, 37, 74, 25, and 49, each number here is called an element. Okay, the order of this matrix is what? We also consider that first we write the number of rows, which is 2, by the number of columns, which is 3. So we say that the order of this matrix is 2 by 3. Why 2? Because we have 2 rows. Why 3? Because we have 3 columns. So the order of this matrix 2 by 3, 2 rows and 3 columns. Okay. Generally, we say that the order of a matrix in general is m by n. What is m? M and n must be belongs to z positive. Z positive means no fraction, no decimal. It's only 2, 1, 2, 3, 4, and so on. Okay, so in general, the order of a matrix equal m by n, such that m is the number of rows, n is the number of columns. Okay, let's move, my dear students, to the next example. Yes. Okay, let's move to another example here. What is the definition of matrix then? Definition. We can define the matrix. Definition of a matrix. What is the matrix? We have already write numbers or elements inside the matrix. So it is tabulating. It is tabulating as a table a set of elements. Okay, put in the form of horizontal rows. Put in the form of horizontal rows and vertical columns. Okay, and are put inside it. What the put numbers inside it? We put elements inside it. Okay, we write it as this shape. We have a row here and another row. We can write third row. Okay, and we have columns. We have rows and columns. Okay, this rows called M, and this number is M, and the number of columns is N, so its order is M times or by N. M and N belongs to Z positive. Okay, let's move to another thing. We have an exercise here. Okay, it's very exercise and very easy. Okay, let's move to an example here. This example say about a leather factory. You know about leather factory produces three kinds of shoes, bags and belts. Okay, let's write the following numbers. This factory is a leather factory. This leather factory produces three kinds of products. We have shoes and bags and also belts. Okay, and we have also two branches. The first branch called A, the second branch called B. Okay, the first branch produce 140 shoes, 180 bags, and 120 belts. The second branch B produce 110 shoes, 200 bags, and 150 belts. Okay, we can make this as a table here, but we can simplify it as a matrix. Okay, we can write it as a matrix. Don't write shoes, bags, belts, or branch A or B. We just write the matrix, two parentheses as this, and we write the numbers 140, 180, 120, 110, 200, and 150. So I'll ask you, what is the order of this matrix? Yes, we have here two rows, so there is 2 by. We have here 3 columns, so it's 2 by 3. 2 rows and 3 columns. It's the order of this matrix. Okay, so we can use another method to write this matrix. Okay, look carefully here with me. We can write it like that. We have here shoes, bags, and belts. Okay, and we write here branch A and branch B. Branch A produce 140 of shoes, 180 of bags, 120 of belts. Branch B produces 110 shoes, 200 bags, and 150 belts. So it's another method or another way to express this data. We can consider them as a table here. Okay, And we can write them as a matrix here like that. We have write 140, 180, 120, and this side write 110, 200, 150. So here we have written these data by another matrix, but this matrix has how many rows? Has 3 rows by how many columns? 2 columns. So its order now is 3 by 2. The same data, we have written them by 2 methods of matrices. This matrix first here, and this matrix. This matrix has 2 rows and 3 columns, but this one has 3 rows and 2 columns. They are the same data. We will call this data here, this matrix is a transpose of this matrix. Okay? Let's move to another example here to how to express the elements of a matrix. If we have a matrix here and we have a data inside it, this data, if the matrix is capital A here, by the way, we express the whole matrix by capital letters A, capital B, capital C, capital X, capital Y, capital Z, and so on. These matrices, we express them by capital letters. But the elements here, we express them using small letters. Okay? If we have a capital A for this matrix here, then we have elements here. This element here, we can say it small a, 1, 1. Why 1, 1? Here this element lies inside the first row. So we have 1. And it lies also in the first column. So we have other 1. So we write it as A11. And the second element, we called it A12. Why 12? 1 because it lies in the first column. Row number 1 and the column number 2. This element will be A13. This element lies in first row, the row number 1, and third column, the column number 3. Okay, now you can complete with me. We have this element here. We can write it A21. Yes, A21 because we have second row here, the row number 2, and first column here, the column number 1. And this is A22, A23, and if we write here, we will write what? Yes, we will write A31 because it is row number 3 and column number 1. A32 because we have row number 3 and column number 2. A33 because we here in the third row and third column. Okay, generally we use small a, ij. What is I? What's j? Small a expresses the element itself, and I expresses the number of rows. J expresses the number of columns. So we will revise again. Capital letters used only for the matrices itself. Okay, but small letters expresses the elements inside these columns or these matrices. This is A11, A12, A13, A21, A22, A23, A31, A32, A33, and generally we call it Aij. I expresses the number of rows, and J expresses the number of columns. Okay, let's now move to an example here. If we have, okay, let's write the example. If A is a matrix and this matrix written as -2 here, 0, half, 1, 6, -4, and we have B is another matrix, 4, 5, -1, 8. We have C, the third matrix here, 3, -3, √5, -1, 0, -2, 2, 1/4, 9, and we would like to find what? To find the order of each one. The matrix A of order what? Yes, we have 2 rows, so it's 2 by 3 columns, so 3 columns. The order of the first matrix here, which is A, 2 by 3. Okay, matrix B of the order 2 rows and 2 columns, so it's 2 by 2 order. This one, C, let's count 1, 2, 3 rows by 1, 2, 3 columns. So its order is 3 by 3. Okay? And would like to write the following numbers. What is A to 2? Look careful at this. Because it's small a, so it's an element here inside the matrix A. A to 2 means the element that in the second row and second column. Second row and second column is this number. Second row, second column in this number, so it's 6. If you want to find out the element B to 1, the element small b to 1 lies in the matrix B. So B to 1 means the element in second row, which is this row, and first column, which is this one, so it's -1. B, we can say C32. C32. We have here small c, okay, so it is an element in the matrix C, and 3 means the row number 3, row number 1, number 2, number 3. Concentrate in the row number 3 and column number 2 here, so the number will be 1/4. Again, we have the row number 3 and column number 2, the intersection number or point 1/4 here. So C32 equals 1/4. Let's practice here another one. If we have C23, what C23? C2 means the second row, 3 means the third column, so it's -2. B to 2. B to 2 lies in the matrix B, the second row and second column, so it's equals 8. Now we will move to another example here. Okay. the question is write by listing here, by listing. Number 1, the matrix A, capital A for the matrix, as we know, which is equal A ij, such that I equals 1, 2, and 3, and j equals 1 and 2. We will draw here 2 parentheses like that, and we have the capital letter A for the matrix, and we will write here A11, here A12, and A13. Okay, and I equals 1, 2, 3, so I here the number of rows 1, 2, 3. J expresses the number of columns, so we will have 2 columns. Okay, so we will write A11, A12, A21, A22, A31, A32. Why we cancel that? We have cancelled that because we have 3 rows here and only 2 columns, the first column, the second column. So it will be only this matrix. Okay, we cancel that. So if we have I 1, 2, 3 and j 1, 2, so we write A11, A12, A21, A22, A31, A32. Okay, let's move to another example here. We have many examples, and it will be easier for you because we will deal with numbers. So if we have an example here like that, A equals a matrix, this matrix 4, -1, -5, and 2. And we have another matrix B equals -3, 2, 0, and 1. Okay, and we would like to find out A plus B. A plus B means the adding of 2 matrices. Now they must have the same order to add them. The order of the first matrix here is 2 by 2. The order of the second is 2 by 2 also, so they have the same order. To find out the adding of A plus B here, we write A like that and B like that. A, write it again for -1, -5, and 2, -3, 2, 0, and 1. And we will add the element 4 with the element -3. Concentrate well with me. 4 plus -3 equals 1. And also we will add -1 plus 2. The answer will be 2. We will add -5 with 0. -5. Okay. 2 plus 1 equals 3. Okay. We have added the number and its converse. Okay. So we add 4 plus -3 equals 1. -1 plus 2 equals 1. -5 plus 0 equals -5. 2 plus 1 equals 3. Okay, my dear students, we have a little break and we will return again. Stay with us. Thank you.